Station. This is Houston. Megan, are you ready for the event?
Tracy, I'm ready for the event.
Scripps Institution of Oceanography. This is Mission Control Houston. Please call station for a voice check.
Station, this is Brittany Hook with Scripps Institution of Oceanography. How do you hear me?
Hello, Brittany. I hear you loud and clear.
Hi, Megan. This is Brittany Hook with Scripps Institution of Oceanography. Many of us here at Scripps and UC San Diego have been following your incredible journey, so we're very excited to hear from you today. Some of our questions were submitted by members of the Scripps community. And our first question comes from recent graduate Rachel Chen, and she asks, what made you decide to become an astronaut, and did your time and education at Scripps influence your decision?
Thank you for the question, Rachel. So when I first thought about becoming an astronaut, I was a teenager. I lived at Moffett Field Naval Air Station. My dad was a pilot there, and we used to see astronauts come for training for shuttle landings, actually. And that's kind of when I first realized this is a real job that real people have. And so that was sort of the first clue. And I had grown up around aircraft, actually, and was very interested in airplanes, and aerospace engineering became what I studied in college. But I knew that, working for NASA, even being an astronaut, would be a long shot. And as a maybe a junior in college, I got involved with some other students, and we built a human-powered submarine. And I had not been interested in oceans terribly before that, so that was kind of my first exposure to living and working underwater and around the water. And so building the submarine and becoming scuba certified in order to pilot the submarine was kind of a real big life-changing experience for me. And that's when I first started to think about how exploring the oceans is in a lot of ways similar to exploring space. And so that career shift for me, going from aerospace engineering to ocean engineering and ocean exploration, that happened, of course, when I went to Scripps. So, of course, Scripps played a huge part in that. And the experiences that I had going to sea and operating on ships and also, on shore, but using equipment offshore, all of that, I think, plays into living in a spaceship that's not on the planet, right? A lot of similar operational concepts. You have to have all of the equipment that you need to do your work. You have to be able to fix the things that break, and you have to, have a plan, go by the plan, and then adapt when things don't work out quite according to plan. So a lot of relations between, my experiences at Scripps and my experiences in space.
Thank you, Megan. Also love the Scripps shirt. Our second question comes from undergraduate Carlos Garcia. He says, as an oceanographer, what is the most informative experience you've had, given that you've studied the ocean from two very distinct vantage points, below sea level and now in orbit? Has this unique perspective given you new insight?
Carlos, it's a really interesting question, and I'm not sure that I have a really great answer, but I think it will inform, how I think about this experience. In terms of observing the ocean from space, unfortunately, I haven't had a lot of chances to do that other than informally. And so I think it's maybe more of a philosophical or even emotional experience that you have when you observe our Earth from low Earth orbit, and you see we're an ocean planet. Earth is an ocean planet for sure. As you guys know, you're studying the oceans. 70% of our Earth is oceans. And so seeing that, realizing that, seeing it from space, and then seeing, the thin lens of atmosphere that's what keeps our planet and all of us safe, our spaceship Earth, if you will, it's a very strong, you have a very strong feeling about that, a very strong reaction. It's in some ways similar to the feeling you have when you're out on a ship and you're, out of sight of land for days at a time, and you realize, this is an ocean planet. The oceans are so important to the health of the planet and of course, ultimately ourselves. And so just the value, the importance that we should place on keeping our planet healthy, it's something that I experienced both when I was studying the oceans and now living and working in space.
Very cool. We recently learned that you helped collect some samples on board the space station for a study on microbes led by Scripps and UC San Diego scientists Megan Timmis and Jack Gilbert. Can you tell us more about this work or some of the other research investigations that you're working on right now?
Well, I can sure give it a shot. I'm sure that Megan or Jack could tell you a better version of the research that they're doing. You know, we're kind of the hands that collect the data for them up here. But I was very excited also to learn that this experiment that we were conducting, we conduct hundreds of experiments up here, and it was neat for me to learn that this is one from Scripps, from my alma mater. So my understanding is that we're looking at the microbiome that's here in this isolated, closed environment. You know, everything, all of this microfauna we bring up with us, right, on our bodies. And so how does it potentially change in this closed environment? Does it become, can it potentially become dangerous to us in some way? And so my piece of that, of course, is the operational piece is collecting the samples, and then the PIs there at Scripps will actually do the investigation looking at the genome of these microbiome and, you know, fungus or whatever it is that we've collected. And so the part that's interesting for me up here is figuring out how do we sample, how do we, you know, follow sterile technique in this environment where, you know, I'm floating all the time. And so, you know, you watch a video of someone putting on sterile gloves and they're using a table to do that. I don't have a table to do that. You know, everything I have is going to float away from me if I don't think about very carefully how to do every one of these steps. And so wanting to, you know, make sure that I do a really good job for any PI that we're involved with really involves kind of thinking through every step. Where am I going to put each object that I'm using to, you know, maintain sterile technique while I'm sampling this area? And it's probably something, you know, becomes second nature to you all on Earth when you're taking samples, but really have to think very carefully about how we do it in a micro-G environment.
Thank you, Megan. A master's student named Allegra Lafair asks, I read that you were juggling both finishing your PhD and starting astronaut training within the same time period. Can you tell us more about that time in your life and how you handled the two?
Yeah, so that was a really kind of a crazy time in my life when I got the phone call to ask me did I want to come to work as an astronaut candidate. Of course, I said yes. I was very excited, and I went and talked to my advisor, Bill Hotchkiss, and you know, we talked about what was the forward path for me, being, you know, hopefully close to finishing out my thesis, but not done yet. And we talked about, you know, should I take the work that I had done and, you know, write a master's thesis and be done with it, or, you know, would I invest the time, you know, going forward in making sure that I finished the PhD dissertation? And so it was really important to me to finish that work, all of the people that had helped me along the way, and important to myself as well. But figuring out how to juggle those two things where astronaut training was very intensive, especially for the first 18 months, how was I going to stay involved with my research as well, which was completely different than the training that I was doing at NASA. And so I would, on weekends and periodically when I had a week off at NASA, I would go back to the lab and do some of that work. But it really took, once I finished my astronaut candidate training after about 18 months, I took an unpaid leave from NASA and I moved back to San Diego. I lived in my advisor's house, and I was at the lab all day, every day, really trying hard to get through the work and finish and be able to defend. And I was able to do that with a lot of great support. And I'm so glad that I did. At the time, it seemed impossible that it couldn't be done. But I had great supporters at NASA who said, hey, you put all this work in, you really need to go and finish this, and we'll give you the time to do that. And so it seemed crazy at the time, but it all worked out, and I'm really glad that I ended up doing it.
Yes, that is definitely impressive that you did both at the same time. Another incoming master's student named Heidi Tate asks, what is the biggest technical challenge caused by zero gravity that you've had to overcome when doing bench work for medical or other biological research?
That is a great question, Heidi. And I will say also, not being a biologist by training myself, not a lot of bench work in my lifetime up until now. A little bit of training, obviously, but not a whole lot. So one of the things I wanted to show you, this is our life sciences glove box here. Normally it's pushed back and stowed into the rack over here and covered up. But Aki, my commander, was using it earlier today, so I asked him to leave it out to be able to show you. And so this is where we do a lot of that bench work, a lot of that life sciences work, where we're working with human cells or animal cells, and so we need to have that in this closed environment. And so the way we do that, actually, we have a footrest that's over here, and then my hands go into the glove rings right here. And then the work obviously done inside the volume. One of the things that's very challenging is working with fluids in space. And so the fluids can get bubbles entrained in them, and you're trying to very carefully measure out a certain amount of fluid, obviously, in your pipette to create a sample that's a very known quantity, but you get bubbles entrained in them, and they don't react the way they would in a 1G environment. And so figuring out how to get the bubbles out of the fluid, and of course different fluids in different vial sizes can behave very differently, and so it's a learning process as you go along, and you're learning techniques real time to kind of work around those challenges. One of the things we did in here with an immune study was we had these open wells, a plate with 24 open wells, and we had to transition it from this environment into the incubator over here. And of course I can move a plate like this, to on its side to upside down, and in microgravity the liquid's not going to spill out. But if I move quickly, if I give any jolt at all to it, it will absolutely spill. And so thinking about how to move when there's not a lot, I can't just walk. I have to figure out how to place my feet, how to place my hands, how to do this transition. It felt very much, Mission Impossible when we were doing that transition, wanting to be very careful to be graceful and gentle with the samples to preserve them.
Thank you, Megan. Master's student Isha Rangani asks, do you think we can make a connection between life in our oceans, specifically deep sea extremophiles, and extraterrestrial life? Can the deep sea give us a better understanding of the possibilities of extraterrestrial life?
Well, my thought is that absolutely, that extremophiles in our deep oceans and other environments on Earth can absolutely give us, can inform us as we're looking for signs of life or past life on other planets. We have moons in our solar system that may harbor oceans that may have signs of life or past life. And so by broadening our understanding of where life can exist, that absolutely can help us in that search. So I think traditionally we used to think that, all life is going to be carbon-based life. It's all going to, look somewhat like life that we are familiar with. But even in the last, 40 years on our own planet, we've discovered life in areas that we would have never suspected could sustain life. And so I think that broadening of our understanding is absolutely going to inform our search as we go forward.
Thank you so much. Postdoctoral scholar Leah Siegelman asks, I know that you have a young child at home and that you are married to another NASA astronaut. How do you balance your work and family life?
I think that work and family, that life balance is difficult for families to achieve. In particular, maybe families where both partners are professionals that work in intensive jobs where maybe travel is required or unusual hours are required. And so kind of our experience is similar, I think, to a lot of other people's experiences. And a lot of times you end up taking turns. So when you're going to have an intensive work period, then the other person maybe dials back down on their work. So for example, when my husband was developing the Crew Dragon, and that took several years, I was doing a job that required less travel and no space travel. And so we kind of have to hand that baton back and forth and take turns with who is going to have the more intensive schedule, who is going to be doing more of the travel, so that our son has parent, we would say a parent with boots on the ground at home all the time. And we also have really great support that we have found in our local area, where unfortunately we don't have family in our area, but we have found some great friends and neighbors that have really helped us out and just kind of built a village to help take care of our son, which is wonderful.
Thank you, Megan. Lauren Bulletin, an undergraduate intern, wanted to know, knowing where you are now, what advice or encouragement do you wish you could go back and tell yourself as a student or early career scientist?
That's a really good question, too. I think that one thing I would tell myself is to not be afraid to ask questions. I think there was a point in my career when I was younger, undergraduate in particular, where I thought, okay, I didn't really understand that, but I don't want to ask questions here in the classroom or in this larger group setting. I'm going to go figure this out on my own, or maybe I'll, go to office hours and see if I can get some help there. But as I've gone through my career and realized, a lot of times there's other people that don't understand the same thing I don't understand. And also, it's really important that I understand these things. Graduate school was definitely helpful. My advisor was wonderful with he could tell kind of from the look on my face, hey, maybe she's not getting this. And he always had 2 or 3 ways that he could help me, walk me into understanding different things, which was great. But, in the job I have now, I really need to understand stuff because my life or someone else's life could depend on it, or, the science that I'm doing, if I don't understand it, this is someone else's science and I could really mess it up. So the importance of understanding, really, it just gives you the courage to, hey, if I don't understand this, I'm going to go ahead and ask questions. And so I think that's important for all learners, for all people who are curious. Go ahead and ask the question, make sure that you understand stuff, and don't feel like you have to do all of that on your own.
Thank you, Megan. Great advice. Emma Hoffman, an undergraduate, also asked, I was wondering if Megan could do anything differently about her grad school journey, what would it be? And if you could also describe a little bit about what your college experience looked like.
Sure. When I think about my college experience and my graduate experience and, kind of how I got there here, it does seem like, wow, maybe there was a straighter path. But sometimes the straighter path is not the more interesting one. And I think I really learned a lot along the way. And you have to give yourself permission, I think, to, that thing you decide when you're 15 or 16 or 17 that's going to be the thing you do. You're really going to probably change your mind, and you have to give yourself the permission and the freedom to explore those things that you become passionate about. So I'm not sure that I would really do much differently in terms of how I pursued my education. I think starting off in aerospace engineering at UCLA, for undergraduate was tremendous. I learned a lot there. I had a lot of great friendships there, and being part of the human-powered submarine team for UCLA then was really, was my first experience of getting some hands-on project engineering time and building something, budgeting for it, doing all of those things with a small group of people. Really was a great engineering experience, but then it also introduced me to the oceans and the idea of ocean exploration. And I did struggle with that for a little while to figure out, hey, should I make this crazy left turn or should I stick with, this thing I started with? And I was given some great advice actually by Kathy Sullivan, who is another astronaut and oceanographer, and she said you really have to pick that thing that you love doing. You can't, stick with something just because you think it's what NASA wants, because the chances that you get picked by NASA are really slim. So figure it out what it is that you're passionate about, and then do that thing as well as you can do it. And that was great advice, and I felt like it really helped me make the decision to pursue oceanography, which I was becoming passionate about and wanting to learn a lot more about that. But I did always kind of keep the idea in the back of my head that, wouldn't it be great to be an astronaut one day? And so that was kind of, guided my overall path, if you can call it being a guided path. But I think there's a common thread there, that thread of exploration and discovery that kind of goes through all of those things.
Thank you, Megan. Thinking back to your time at Scripps, do you have a favorite memory or experience that you can share with us?
I have so many good memories from Scripps. It's actually pretty hard to pick a single memory, but I think a lot of the great memories have to do with the operational experiences that I had. So the time that I had on ships, the time that I had on Flip was amazing. Getting to help other students with their research, a ship that would go out and have a bunch of people on it all trying to collect different kinds of data, different kinds of animals. And, as an engineer, for me, that was really exciting to get to volunteer with them and help with lots of different projects, and then again working on my own projects where we'd go out on Flip, or we'd deploy instruments in the water and come back and then use those instruments over time to record data. So all of those operational experiences, the camaraderie that you develop when you're in these weird situations, when you're on ships and maybe somebody gets injured or maybe your equipment isn't working and you have to work through that situation, those create some really good memories when you solve those problems together.
Thank you, Megan. And then our final question is, what has been the most impactful moment of your career thus far?
Wow, the most impactful moment of my career thus far. That's a great question, and I'm not sure that I have a single answer. There's been a lot of moments that stand out for me as very memorable, and they usually have to do with new opportunities opening up. So I remember the phone call that I got from Bill Hodgkiss telling me that I was accepted at Scripps. I remember the phone call that I got from Bill Parsons telling me that I was accepted by NASA. So those are kind of memories that stand out. But the experiences, again, are kind of the team experiences that I've had working together with other people to achieve something or to solve problems.
Thank you, Megan. Well, thank you so much for taking the time to participate in this Q&A with us at Scripps. We're all so excited to follow this journey from oceanography to going up to space. So thank you so much.
Absolutely, Brittany. Thank you. Thanks to you and to all the team there and all the students and staff and faculty for following along the mission, for sending me your support. I love the patch that you all made to follow the mission. So thank you to that team that put that together. And just thanks for the great support. Thanks for helping to get me here.
Thank you.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from Scripps Institution of Oceanography. Station, we are now resuming operational audio communications.